So in this question, you're given that the sides of triangle are 17, 25 and 28. You're asked to find the length of the longest height of this triangle. So what is the concept of longest height of a triangle? So if you have a triangle, let us call it A, B, C. You have three sides, small a, small b and small c. Now let us say that HA is the height corresponding to the base A, and HB is the height corresponding to the base B, and HC be the height corresponding to base C. Now what is the area of this triangle? So the area of this triangle is given by half times A times HA. If you take A as the base, HA is the corresponding height, or I can also write the value of delta area as half into B times HB, or as equal to half times C times HC. So all these three values has to be same as the area of the triangle. This implies A times HA should be equal to B times HB is equal to C times HC. That means the ratio of ABC is inverse to the ratio of HA, HB and HC. The product of A and the corresponding HA is same. That is, if the base is large, the corresponding height will be small, such that the product is equal. So the greater the side, lesser the corresponding height. So if I want the longest height, I have to find the height corresponding to the shortest side. So out of these three, the shortest side is 17. So the height corresponding to this shortest side will be the longest. So that means if I take this as A, if I take this as B, if I take this as C, A is the shortest side. So I need to find height corresponding to A, which will be the longest. So how do I get it? First, I'll get the area of the triangle by a different formula. Because I know all the sides, I can use Heron's formula. So delta is equal to root of S times S minus A into S minus B into S minus C. So what is S? S is a semi-perimeter. 17 plus 25 plus 28 by 2. So it is a 30, 40, 50, 63, 70 by 2 is 35. So that is equal to root of 35 times S minus A. 35 minus 17 is 18. 35 minus 25 is 10 into 35 minus 28 is 7. So that is equal to, so within 35 you have a 7 and a 5. So 2 7s, you get 1 7 outside. So 5, so within 10 you have 5 into 2. So you have 2 5s here. So you get a 5 outside. So 8 into 36. So you get a 6 outside the square root. So the area of this triangle is 7 times 5 times 6. I don't need to calculate it right now. And this has to be equal to half times A times 17 times height corresponding to A. So that means the height corresponding to A is, so 2 times 7 times 5 times 6 by 17. So 7 6 are 42 into 10 is 420. So 420 by 17 units. Whatever are the units in which the sides are measured, in the same units you get the height of the triangle corresponding to the shortest side, which will be the longest height. So this will be the required answer. So in this question, you're given that you have an equilateral triangle ABC and D is an interior point to this triangle, and the perpendicular distances of D from the sides are 4, 5 and 6. If that is so, what is the area of the triangle? So you're given that you have an equilateral triangle. Let us call this ABC. An equilateral triangle means that all the sides are same. Let us call them AAA. and you have a point D within this triangle. Obviously it's not equidistant from all the three sides, so you have some point D like this, whose distance from one side is 4, whose distance from the other side is 5, and whose distance from the third side is 6. So you have a point D such that it is at a distance of 4 units from one of the side, 5 units from the other side, and 6 units from the other side. So if this is so, what is the area of this triangle? So what should be the side of the equilateral triangle so that this point D will be possible within the triangle? So what I do is, I'll do some construction. I'll join D with each of the vertices. I'll join D with each of the vertices. Now I got 3 triangles. Let us take the first triangle. So what is the area of this triangle? So A, let us call this A1, is equal to half into base is A into this 4 will become the height of this triangle, right? And if you take the next triangle, if you take this triangle, A2 should be equal to half times A times 5, half times A times 5. And if you have A3 is, let us consider this area as A3. So A3 will be equal to half times A times 6. Now if you add all these areas, you should get the total area. So the total area of the triangle, which is root 3 by 4a square, because it is an equilateral triangle, we know that the formula is root 3 by 4a square, should be same as the sum of these three. It is half a times 4 plus 5 plus 6. So these two have to be exactly same. By equating these two, 1a gets cancelled. So a will be equal to, so this 2 and this 2 gets cancelled. So 2 by root 3 times 4 plus 6 is 10 plus 5 is 15. That is equal to, so if you cancel this root 3 out, you get 10 root 3 as the answer. So if a point D such that these distances are valid, then the side of the equilateral triangle has to be equal to 10 root 3. Now once you got this side of the triangle, you can easily find the area. So area is equal to root 3 by 4 times a square is nothing but 3 times 100. So 25, so that is equal to 75 root 3 square units. So this will be the required area of the triangle. So in this question, you're given that the sides of a triangle are 6, 7 and 8. And the line through the incenter parallel to the shortest side meets the other sides at P and Q. If that is so, what is the length of PQ? So you're given that you have a triangle whose sides are 6, 7 and 8. It's a scalene triangle. So let us say this length is equal to 6, this length is equal to 7, and this length is equal to 8. Now you take the incenter of this triangle. So let us take this as the incenter, somewhere inside the triangle. So let us call this triangle as ABC. So a line through the incenter parallel to the shortest side, which is equal to 6. So if I draw a line parallel to this, parallel to the side BC through the incenter, it's given that it meets the other two sides at P and Q. So if that is so, what is the length of PQ? That's the question. Now, so what can I do here? So first what I do is, I'll draw a perpendicular from incenter to the side BC. And this will be equal to the in radius of this triangle, right? And next I'll draw an altitude from A onto BC. If I draw an altitude from A onto BC, this will be the height corresponding to BC. So let us call this HA, the height corresponding to BC. Now can I find the value of R? Yes. Can I find the value of HA? Yes. I have standard formulas to do that. So small r will be equal to delta by S. Small r will be equal to delta by S. This is the formula of incenter. And what is HA? Delta can be written as half times 6 times HA. The area of this triangle is half into 6 into HA. So this gets cancelled 3 times. So height correspond to A can be written as delta by 3. So now if you carefully observe this diagram, can you see that the triangle APQ and ABC are similar to each other? Triangle APQ is similar to triangle ABC because these two lines are parallel to each other, and this angle is same as this angle, and this angle will be same as this angle, and angle A is common. All the angles of this triangle are same as the angles of this triangle. Hence these two triangles are similar to each other. So now once they are similar to each other, the ratio of their sides is same as the ratio of their heights. So the ratio of their sides, which is PQ by BC, I am not writing all the sides, I don't require all the sides. So PQ by BC is same as the height of this small triangle by the height of this big triangle. So what is the height of this small triangle? HA minus R. The total height is H. This length is R. So HA minus R is the height of the small triangle divided by height of the total triangle is HA. And this implies what is PQ by BC. PQ is unknown here. BC is 6 is equal to 1 minus R by HA. And R by HA can be found out from this. So R by HA is equal to delta and delta gets cancelled. You get 3 by S. And what is S? S is a semi-perimeter. S is equal to 6 plus 7 plus 8 by 2, which is equal to 21 by 2. So if you put 21 by 2 here into 2, that is equal to 2 out of 7. 2 out of 7. So R by HA is 2 out of 7. If you just put that, 1 minus 2 by 7 is equal to 5 by 7. And PQ is equal to 30 by 7 units. So that will be the length of PQ. So in this question, you're given that the ratio of the sides of a triangle is 3:7:8. So if that is so, you're asked to find the ratio of circumradius to inradius. So how do we do this? We know the basic formulas for capital R and small r in terms of ABC. So small r is equal to delta by S, and capital R can be written as ABC by 4 delta, because delta is equal to ABC by 4 capital R. R can be written as ABC by 4 delta. So capital R is to small r is equal to ABC by 4 delta square times S. So if I can find this value, then I get the ratio of capital R by small r. A is to B is to C is given. So I can take A is equal to some 3x, B is equal to some 7x, and C is equal to 8x, right? Because that's the ratio in which A, B, C are there. So now once I know A, B and C, I can as well find the value of S as well as delta. So delta can be found using the Heron's formula. So to find that, first let us find S. S is nothing but the semi-perimeter. 3x plus 7x plus 18x by 2. 3x plus 7x plus 8x by 2, that is equal to 9x. So S is equal to 9x. So we have ABC, that is 3x into 7x into 8x times S is 9x divided by 4 times delta square is nothing but S times S minus A times S minus B times S minus C. So S is 9x times S minus A, you have 6x, into S minus B, you have 2x, into S minus C, we have X. So this is ABC into S by 4 times delta square. So now cancel out the terms which are common in numerator and denominator. So 9x and 9x are getting cancelled. So all the x's gets cancelled, as you can see. All the x's gets cancelled. So 3 2s are 6 and 4 and 2 gets cancelled with 8. So you are finally left out with 7 by 2. So capital R by small r will be equal to 7 by 2. So in this question, you're given that delta is equal to a square plus b square minus c square. If that is so, you're asked to find the value of tan c. So how do we do this? So let us try to analyze tan c. So tan c is nothing but sin c by cos c. You need to find this. And sin c can be written as, so we know from sine rule that a by sin a is equal to b by sin b is equal to c by sin c is equal to 2r. This is sine rule. So what can I write sin c as? Sin c can be written as c by 2r. This is c by 2r times what is cos c? From cosine rule, we have a square plus b square minus c square by 2ab. So this 2ab goes into the numerator. You have 2ab. So this 2 and this 2 gets cancelled. So you get abc by r times a square plus b square minus c square. That means if you want tan c, you need to effectively find this. Now what is the given information? The given information is delta is equal to a square plus b square minus c square. And what is the formula for delta in terms of capital R? Because tan c is in terms of a, b, c and r and a square plus b square minus c square. So we know that the formula for delta is ABC by 4 times capital R is equal to a square plus b square minus c square. So this implies I need to find this. So what I do is ABC by 4 times a square plus b square minus c square times r is equal to 1. So ABC by r times a square plus b square minus c square, if you cross multiply this, so will be equal to 4. So this will be the value of tan c. So in this question, you're asked to prove that a plus b plus c times b plus c minus a times c plus a minus b times a plus b minus c by 4b square c square is equal to sine square a. So let us start from the LHS. So the expressions that you have in the numerator are very standard expressions. A plus b plus c is nothing but 2s. B plus c minus a is 2 times s minus a into 2 times s minus b into 2 times s minus c by 4b square c square. That is equal to, so if you take these 2's outside, you have 16 s into s minus a into s minus b into s minus c. From Heron's formula, this is delta square by 4 b square c square. And if you cancel this out 4 times, that is equal to 4 times, what is delta square? So one of the formula for delta square or delta is half bc sine a. So delta square is a whole square by b square c square. So you should understand why I have written only this formula, because finally I want sine square in the RHS. It means b square and c square has to get cancelled out. So I'll write a formula where b square c square can be cancelled out. That is equal to 4 times 1/4 b square c square sine square a divided by b square c square. 4 and 4 are getting cancelled. B square c square and b square c square are getting cancelled. So is equal to sine square a, which is the RHS, hence proved.